So determinants is our last section. So we're going to define and calculate determinants, and we're going to use determinants to find areas of regions. Okay. So to define and calculate determinants, what does that mean? The determinant is a number associated with any squared matrix. The key thing is that it only works with squared matrices. Okay. Meaning that 2 by 2s, 3 by 3s, 4 by 4s. Okay. If A, which we're going to call matrix A, is a square matrix, then the determinant can be written as this. So if it asks you for, it looks like it's saying absolute value of A, of matrix A, but it's asking for the determinant of A, or it can be stated as DET of A. Okay, determinants are used to characterize invertible matrices. A matrix is invertible if and only if it has a non-zero determinant. If your determinant comes out to be 0, that means that you cannot find the inverse of this matrix. Okay. And that's because when we talked about inverse matrices before the break, which I know was a while ago, we talked about that you have to multiply by the reciprocal of the determinant. And if you have a 0 in the denominator, can you multiply anything? Nope, because it becomes undefined. Okay, so what does it mean? If your determinant equals 1, it means that there are no magnifying properties. That just means that it's not going to change. It is what it is. If it's less than 1, then the determining, if it's less than 1, the matrix has magnifying properties. If it's greater than 1, the matrix has shrinking properties. And then if it equals to 0, it will shrink an object to a dot. So like it's just changing the size. And this goes back to linear transformations, which we don't focus on in this class, but that's what these are referring to. So first thing first is determine if A inverse exists by computing the determinant of the matrix. Finding the determinant is super duper easy. We talked about it before. Do y'all remember what we're doing? What do we do? There we go. We are multiplying the opposites and switching the signs. So let's go back. I'm going to go back to the other one for a second. So the first thing you're going to do is you're going to multiply. Is literally just cross multiplying, and by flipping the sign, it means you're subtracting. Okay, so we're cross multiplying and subtracting. This is essentially all you're doing. So notice here we did 4 times 4, then we did 5 times -6, and you're subtracting. That's what the flipping of the signs means. When you're finding the full-on inverse, that's the switching of the places and changing the sign, and then you multiply. But just finding the determinant only. Here you go. And it equals 46. If it equals anything other than 0, then that means that there is an inverse possible. So notice here, this equaled 46 by doing all of that. So the inverse is possible. We're going to look at example B. We're going to cross multiply and then subtract. So notice here on example B, when we cross multiply and we subtract, it equaled what? 0. So that tells us what? That the inverse does not exist. Do you think you can identify whether an inverse exists or not? Yes? Doable? Okay. Now, what happens if if it's a bigger matrix? Well, you have to use your minors and your cofactors for the matrices. A minor is the determinant of a square matrix formed by deleting 1 row and 1 column from some larger square matrices. Okay, so for example, I have a 4 by 4 square matrix here, and I want to find the minor or the cofactors for 2, 4. What that means is I'm going to eliminate row 2 and column 4. And now I'm only going to focus on these elements left in the matrix. Okay, so if it's telling you that you are eliminating, what are you taking away? And then you're going to focus on analyze just this piece of the matrix that remains. All right. There are various reasons why. It's one, it makes it easier to work with smaller matrices, but also, depending on what you're solving, you may not need certain parts of the matrices. Okay. So for here, find the following minors and cofactors for the matrix A. So if I'm looking for M22, that means that I'm crossing out row 2 and column 2. So what I'm left with is this little guy. So I'm now left with this. Does that make sense? So if I'm looking for the minor, 22, Notice the capital M. I'm eliminating row 2 and column 2. And then the elements that are remaining is my new matrix, and we're just going to call it matrix B. It's a 2 by 2. 2 by 2s are a lot easier to manipulate and work with than a 3 by 3. Okay. How do you feel about a minor? Is that doable, creating smaller ones? So let's try it again. From here, I now can determine the determinant of this B, right? I say, okay, I can cross multiply, extract, and determine the determinant of B. Okay, now let's look at it again. So here, this said M21. So if I have M21, yes, M21, which means I'm eliminating row 2, column 1. And when I eliminate 2 and 1, I'm left with a new matrix. And can I easily find the determinant of this matrix? All I'm doing is cross multiplying and subtracting. So we have 2 times -2, which is -4. We have -1 times -3, which is 3. So we have -4 minus 3, and that gives us -7. So the determinant of the little one is -7. It's the determinant for the minor. It's not it's the determinant for the minor that you created. Okay. What did it ask us to do next? I had a brain fart on what I was doing next. Okay, so what's remaining, those are our cofactors. We've got the determinant of the cofactors. We're going to find the cofactors. So when you're looking for cofactors, what you're asking yourself, it's a weird little formula. So the formula that we're using here is your matrix A, whatever your I and J is. So whatever row and column it has you focusing on, you're plugging them into this rule, and that's going to give you your cofactor. So it said A22, which means that we eliminated row 2 and column 2, correct? So when we eliminate row and column 2, I'm now going to plug them in. So this is going to be my I. This is not my I. This is my I, and this is my J. Oh, that's a cute little J. I did good. All right, anyways. And I'm plugging them into the formula. So the formula is -1 to the I plus J power times your M22. Okay, and so for M22, what was M22? And then you plug it in and you do the math, and this is what's called your cofactor. On your where's M22? We ended up with -2. So M22 equaled -2. And then now you're just multiplying. So when it says M20, this right here is the determinant after your minor. Determinant of minor. So now we're going to do the same thing when we did, let's go back. We did A21. So for A21, we had this. We eliminated row 2, column 1, right? So this is going to be our I, and this is going to be our J. So this time I is 2, J is 1. And then your M21 is the determinant of your minor you created. And what's our determinant? -7. How do we find the determinant? We cross multiply and we subtract it. So what ends up happening here is that we have our I, our J, and this is just telling whether your 1 is going to be positive or negative. Does that make sense? So we'll have 2 plus 1 is 3. -1 to the third power is going to be -1. And my determinant, which was your determinant of your B, was -7. So then my cofactor is 7. Now, the reason why this would be important is if we were doing larger determinants. So if we were finding the determinant of a 3 by 3 by hand, we would need to be able to find all of our cofactors, okay? However, because we're at the end, we're not going to do it by hand. Okay, but I want to make sure that you're understanding the two main things, which are your minors and your cofactors. Okay, so finding the minor, do you feel comfortable finding a minor, creating a minor? And then do you feel comfortable finding the determinant? Yeah, okay. Now, last and be all, we're not going to stress over it. We're going to just practice and putting it in the calculator. Okay, so when you're putting in the calculator, you're going to click matrix and arrow over to math. Once you've put in your matrix, and you're literally going to press 1 for determinant, okay? And then select your matrix that you created. I didn't write out the steps for creating the matrix again because we've already gone through those steps. So we're just going to go through the process. Hello, Sylvie. So here we go. We're going to find the determinant of this 3 by 3. So I'm going to go to second, click on there. I'm going to input my matrix. I have a 3 by 3, and I'm going to put in 2, 3, -4, 0, 3, 1, -1, 1, and 4. So now I've created my 3 by 3. I'm going to go back to my calculator page. To get back to my calculator page, I press second mode. And now I'm going to do some calculating. I want to find the determinant of matrix A. So to find the determinant, I'm going to press second matrix. And I'm going to arrow over to math. Do you see where it says DET? There's the determinant. I'm going to go back to my matrix. And I'm going to select the matrix I created. So now I'm going to click enter, and it's going to tell me the determinant of matrix A is 7. Okay, now that's how it would be done in the calculator. And it's pretty straightforward. So like, no matter how large it gets, how big it gets, it would be done in the calculator. Now I'm going to show y'all a video here in a second of a determinant without the calculator. All right, so we're going to watch Patrick do this on like super speed. Okay. We're gonna up it up a little bit. All right, go Patrick. So again, we're following that rule. You're going to first start off with finding your determinant of your first minor. So my first minor is 1. So I write 1, and I'm going to block out everything else. And I'm left with 7, 3, 9, and 5. Minus, now I'm going to do the second one. So now here, I'm going to block out the middle row, the middle column, first row, and I'm left with 2, 3, 8, and 5. Lastly, it's going to be plus. I'm going to now eliminate column 3, row 1, and I'm left with 2, 7, 8, and 9. I'm going to go through and find the determinant of each one of these 2 by 2s by cross multiplying and subtracting. So cross multiply, subtract. And then I keep going. I'm going to cross multiply and subtract. Cross multiply and subtract. PEMDAS tells me I handle the parentheses and then I multiply, right? So I'm going to simplify the parentheses. So we have 35 minus 27 minus 6 times 10 minus 24 plus 4 times 18 minus 56. So we're going to clean that up and we get 8 And we're going to get 6 times negative 14 plus that number. And then you keep doing the math. A negative times a negative makes a positive 84. And then 4 times negative 38 is going to make negative 52. And then you add and subtract from left to right. Remember, it's always left to right. And we get negative 60. And that is how you would find the determinant of a 3x3 by hand. Okay? So that's the wrong thing. All right, so the key thing here is when you're doing it, making sure you're alternating the signs. So it alternates between positive, negative, positive. And yeah, it just keeps going. Now, imagine if you had a 4x4. So for a 4x4, you would take the 4x4, create your 3x3s, then take your 3x3s, and then create your 2x2s. And it just gets bigger and bigger and bigger. And no one wants to do that, right? And so once someone realized the pattern, what was happening, the algorithm for the calculator was built and created. Okay. But a 3x3 by hand isn't that bad to find the determinant. Are there any questions about determinant of a 3x3? Okay, so you have, again, you now have the skills to do it by hand or by calculator. It's totally up to you. All right, so we're going to talk about how is this helpful. This is our final way of learning how to solve a system of an equation. So we've all seen the system ax plus by equals m and cx plus dy equals n. There's this guy named Kramer, and he came up with Kramer's rule. Kramer's rule basically saying that you can use the determinants of your created, but find the matrices created using your outputs, your constants and your coefficients. I'm having brain farts right there. Constants and your coefficients, and you will find your solution. So for example, the rule here is your m and your n. So your m and your n, which is your constants, are going to be the first row in your numerator. And then your y's are going to be the second second column in your numerator. And your denominator is always the same. Your denominator is always going to be your coefficients of your first system in the first row, the coefficients of your second system in the third row. And when you end up simplifying this, you're going to automatically have your solution without going through elimination, substitution, or graphing. Okay. So normally we would solve this by elimination or substitution, right? Ax plus by equals m. So what this is saying is that you can solve it by using the determinant rules. So we're going to practice using the determinant rules. And again, you don't have to use this if you're comfortable with what you're already doing. Does that make sense? So like putting in order. Is that how you solve yours? Yeah. Oh, I guess. Will we go with the clear already? Yes. For all of it? Yes. I did not take it away from you. And we can just solve this with a calculator if we want. All right, so just for fun, we're going to do Kramer's rule because I thought it was pretty cool when I learned it. But so going through, you have we're going to label A, B, and this is what they called M. And this is your C, your D, and this is what they call N. And you're literally just plugging everything in, okay? So to start off with, I'm going to find the determinant of my first one. So your first matrix, let me write it. I'm going to write it all out. So your X equals M, N, B, D over A, B, C, D. So for this problem, I'm looking for the determinant of M and N, which is 118, negative 76. And then B and D, which is 5 and negative 9, over A, B, C, D. And that's going to be your 3, your 5, your 7, and your negative 9. And once you do the math, you're going to have your X value. And you're going to do the same thing for Y, except Y is now going to be A, C, M, and N. Okay. Over A, B, C, and D. So looking here, my A and my C is always 3 and 7. It's 3 and 7, not always. And I have 118 and negative 76. I'm going to find its determinant. And then I have A, B, C, D is going to be the same, 3, 5, 7, and 9. And that's the setup. So once you have it plugged in, how I remember it is that if I'm looking for X, then my constants are my X. If I'm looking for Y, then my constants are my Y. That's just kind of how I remember what's going where. And then you go through the math. So you're going to find the determinant of your first one. That's why it's the 118, 5, negative 7, negative 76, negative 9, and you get negative 682. You're going to find the determinant of the second one, your second numerator, and you get negative 1054. And the determinant of your denominators are going to be the same. So you're going to find the determinant of your denominator. It's just another way. It's just cool little math, how math all ties together. Again, if it doesn't want to be your friend, okay? All you're doing is cross multiplying and subtracting, cross multiplying and subtracting. That's it. So I cross multiply, subtracted. And now I know the value of my numerator for each one. So the numerator here, this equaled negative 682. The numerator here equals negative 1054. I did not leave myself enough room. And now I'm going to find their denominator, D for denominator. And the denominator is the same for both, and we get negative 62. So when I write it out, I have my X equals, my Y equals, so therefore my solution is 1117. Without elimination, without substitution, it's just the last and final way of finding this. Huh? Oh, never mind. Because you're finding X and Y for where they are going to intersect. And the beauty of this is that if your A, B, C, D equals 0, then you know that there's no solution. They're not going to ever intersect. Yes. All right. And that is it. You're done with college algebra.